Hello boys and girls, welcome to our channel. Today we have an interesting question on our hands. If this question looks familiar, it's because it's adapted from a 2019 PSLE Math question. You are given 4 figures of an evolving pattern of blue and green rectangles, and you're asked to fill in the table, which essentially is asking for the number of blue and green rectangles and the total of rectangles in figure 5, which is not drawn. On top of that, you are asked to find out the total number of rectangles for figure 25 and the difference between the number of blue and green rectangles in figure 30. If you would like to give the problem a try, please pause this video now. So how should our thought process be when we see this seemingly difficult question? Well, our suggestion is we start with the easiest question A, and in doing so, hoping to find certain patterns that will help us solve question B and C. So together, let's take a look at question A first. First thing we notice by observing figure 1 to 4 is that there's an increasing number of rectangles. Particularly, there's an additional layer of rectangles of a different color added with each figure. So naturally, figure 5 will be adding a layer of blue rectangles on top of figure 4. And here is figure 5 in its totality. Of course, in exams, due to time constraint, you may just draw a few rectangles on top of figure 4 to help you visualize. With figure 5 successfully visualized, we can move on to counting the number of blue and green rectangles. We know from the table that there are 9 blue rectangles and 16 green rectangles in figure 4. If we focus only on the blue rectangles, it's not hard to realize why, as we see 3 rows of 3 blues, and 3 times 3 is 9. Similarly, if we focus only on greens, we have 4 rows of 4 green rectangles, which is 16. So now we can apply the same method in figure 5 to get the number of blue rectangles to be 5 times 5, which is 25, and the number of green rectangles staying the same as figure 4 with 16. We also know that the number of blue or green rectangles would always be perfect squares. We can then rewrite the tables in perfect squares and summarize the following pattern. For figure n, if n is even, there will be more green than blue rectangles, and the outer layer is comprised of n times n number of green rectangles. Inside, there will be n minus 1 times n minus 1 blue rectangles. If n is odd, there will be more blue rectangles, as the outer layer is comprised of n times n number of blue rectangles. Inside, there will be n minus m times n minus n green rectangles. When you arrive at this pattern summary, we pretty much solved question B and C already, as all that is left to do is to use this pattern to do some calculations for figure 25 and figure 30 respectively. 25 is odd, so blue is the outer layer with 25 times 25 number of blues and 24 times 24 number of greens. After doing a bit of calculation, we would arrive at 1,201 total number of rectangles. Here, we would like to show you another very interesting pattern of perfect squares of 25, 35, up to 95. Notice we can very quickly write down the result of 35 times 35 by calculating 3 times 4, which is 12, and then simply appending two fixed digits 2 and 5 behind to form 1225 as the answer. Can you figure out why? Moving on to question C, same story here. Since in this case n is even, we would have more green rectangles of 30 times 30 and fewer blue rectangles of 29 times 29. Difference between is as simple as calculating two products and a subtraction. Pretty straightforward here. But wait, we're in figure 30 and the difference of blue and green rectangle is 59. Isn't 59 30 times 2 minus 1? Is this another pattern that we just discovered? Well, calculating the difference in the figured rectangles for figure 1 to 5 pretty much confirmed our suspicion. In each case, the difference is always 2 times the figure number minus 1. But why? Why is the difference always 2n minus 1? Well, there's actually a very clever way to visualize and explain this formula. Notice how we can shift the positions of green rectangles in figure 3 to completely overlap with some of the blue rectangles. And the blue rectangles left behind are the difference. Counting these blues, 3 times 2 with 1 double counted, thus minus 1. The same idea in figure 4. Shift, overlap, count the number of leftover greens, 4 times 2 minus 1. So here is a summary of all the patterns we have observed and uncovered during our problem solving. Hope you have enjoyed this journey through this PSLE Math question. See you next time.